So today I want to start with the foundational models, like why we need it, right? So the advantage of it, it's like if I need to build an application, I don't have to create those things from the scratch because it's a pre-trained, so I can easily leverage it and I can create any kind of application very faster. So it can be a translation of the text, or it can be a sentiment analysis, or it can be any other kind of AI driven work that I want to do, right? The advantage is it's very it has really high performance, and because when we use it in big data, like in the cloud environment, if we can optimize the infrastructure, then and we can do parallel processing, then we can run these models very faster. The other advantage of it is like these foundational models can be used in multiple areas, like say for an example in natural language processing or computer vision, and also like in any kind of healthcare or finance area. We can use this foundational model, and the big data foundational model generally uh, like developed on the base of transformer architecture, which is nothing but it goes through the transform architecture flow. I don't have the diagram here, but I can explain. Basically, it goes through from like input embedding, like changing the words or tokens that we tokens to the vector representation. So that's where it starts, the transform architecture. Then it has the encoder decoder functionality, which basically like get this representation of the vector and change it. And then it has go through self-attention layer, which basically checks the relations between the different words. They have some multi-headed approach also, and ultimately it goes through that transform architecture process, and using the feed forward layer, they'll just end up with the output, right? So this is like the base of the foundational model that we create today. But here I'm going to in this session, I'm going to basically show the challenges and what are the best practices, right, of handling this foundational model for a different kind of task. Any question till now, or I can move forward. So
Yeah, go
okay,
go
let
ahead,
me
continue
sure,
because
sure.
we
So
just
the
want to make
next,
sure that you keep going. If they
yeah,
have,
sure.
they can type it in the Q&A.
Perfect. So in case of the big data foundational model, the for pre-training, right? So what we need is like we need the data, right? So and the data comes from various different places, right? So the data collection is very important here. Like it can be a sensor data or coming from any upstream kind of uh, like databases, right? So data collection is very important part. We need to make sure that the quality of the data are good. I mean those challenges that we face every day, right? In any application, be it a data migration application or any kind of application or any modernization application, right? If you have to rate your data, like whether it's good or bad, is the data quality always comes into picture, and obviously the volume, right? If the volume is huge, then it's like we need to handle it, right? Either using parallel processing, or we need to like instance has to be like it has to be have like so that we can scale it basically. If you can scale it, then you can handle this large amount of data. And then as part of the data cleaning and pre-processing, we need to like basically clean the data, in a standardized format. And if there is any missing values or noise, then we need to discard that. And definitely another important part is the storage, like how we'll manage the data. If it is like really huge chunk of data, then we need to make sure like is there any data warehouse or a NoSQL database where we can you know enable the large data set and maintain the accessibility and scalability. So based on that, we can store the data. Apart from that, there are a few other steps generally for foundational model we follow, like curating the data. Like if it is not real, if the some of the parameters of the data are not relevant to the model, uh, it's better to discard it than process it. So basically that will give the that will provide the model accuracy and fairness. So that's one of the steps that we should maintain. Also, the data annotation, it's basically the labeling of the data for any supervised learning when the raw data is coming, right? So, and this is basically we use that for training. Apart from that, we have data versioning and also the lineage. So we track the lineage that from where the data is coming, right? From which source and how the data is getting transformed and how it is going to the end up in the final layer. So this is also a very important step that we have to like check for creating the foundational model. Apart from that, we have to maintain the like privacy and security for the data, like be it in the form of encryption. um, we can use any different kind of encryption technique, and nowadays, like if you are using AWS or any cloud, they have certain standards of encryption algorithms already there. We can use their some IAM role and then encrypt the data over there as well. And obviously, like to create the model, as of today, we are also making sure there are some best practices that we need to follow, like ethical management of the data. So suppose if someone is writing some data which is harmful for others, right? Then we have to use the our ethical AI approach to discard those noise and which is not ethical, right? So that is the another that's a part of compliance thing that we are considering right now that we should use in today's world when we are building a model. So then the next is like the scalability and efficiency of the data. So if it is like a large amount of data, generally we try to do parallel processing, and also we need to like ensure that there is no like data loss because of large volume and obviously like performance another factor, right? If it is very slow or it's getting stuck, then we need to make sure like the infrastructure or or its auto skill is enabled, so that and along with that we need to maintain the cost as well. Like if the cost is very high, then we need to make sure like what's the way we can optimize. um, so this is overall the effective data management is required for pre-training is a comprehensive and a multi-step process which ensures the data high quality data, and that is required, and that's the base of creating the foundational model. So, and the next is a more elaborative on the collection of the data, right? How we are like relevance and the specificity, like utilize the pre-leveled and pre-processed data set for spanning multiple fields and categories. So that's the way like we can do any kind of like we can focus on like in a dataset specific task or the domain. Also like dataset must align with the real world scenarios, like model is expected to address like the quality of the data and the relevance of the data and the criticality and effective fine tuning. I'll talk about the fine tuning and related to prompt tuning after a few slides, but these are the quality control and normalization that we generally take care, and these are the like, best practices for as part of the data collection for building the foundational model. Apart from that, we have data augmentation. So there is nowadays there is a different way of augmenting the data. In some of the cases, if the if we are using any large language model or anything, right? Amazon Bedrock or anything, if there is some data issues are there, and we need to correct it, and again we need to start like basically fix that data, and again we need to retrain or rerun the job. Generally, like we use augmented AI in today's world. There is also a concept of RHLF, which is the so that we can use for to, to do the kind of human check, so that if any error is there, it will automatically fix the error, and it will rerun the job automatically. So that also we can use for as part of the augmentation, which is nothing but refining your data and fine tuning your data. So we can do that in the any cloud environment as well. And so that is also one of the things that generally in industries they use that. Um, so apart from that, like we can do the labeling of the data, which is nothing but ensuring that the variability of the data set and data is labeled correctly for supervised learning. And then for supervised learning, the fine tuning typically requires the labeled data, but proper labeling ensures that the model can learn, generalize correctly. Um, and yeah. So that is the main thing here. Other than that, we have like training, validation, and test set, just to see like how much prediction it is making, which will give us an insight into the how model is behaving. I'm going to the next set for the data storage accessibility. So these are like key highlights for the data storage accessibility, scalability. What are the things that we are considering? One is the efficient access, like optimized data retrieval is essential for fast and effective fine tuning. Another one is the version control. We like tag data versions to maintain like model performance and reproducibility. Another factor is efficient multi-server training, like leverage multiple servers or cloud resources for handling massive data set. The next one is adaptive resource allocation, like dynamically adjust the resources based on the workload demands. So basically, it's kind of scaling. Like also, we have the bias detection and correction, like ensure that the fairness and accuracy of the model uh, based on the addressing the biases if there is any. So we need to track that and remove that. And also the transparency and accountability, basically track and document all the process to build the trust and legitimacy. So it's basically tracks the lineage and how the data is processed, what are the transformation, and yeah. So those are the things that these are the like highlights that we generally consider for creating a foundational model. The next step is like just the high level importance, like in today's world, like we have like task specific performance, that is like fine tuning the data domain, determine the type and the relevance of the data in relation to the target task. So so we can like fine tune our data so that whatever we are expecting the business outcome, that should be like that should match with our expectation and models behavior. Also the ethical AI part is also there, because during fine tuning a particular attention should be paid to control and properly handle the collected data, and to limit the ethical issues, like if it is harmless, then we should not proceed further, and we need to uh, take appropriate response from the model. So that's what we are handling. And for the efficiency and scalability, yes, data management helps in optimizing, fine tuning, and making it more scalable and bringing down the cost of the model deployment in use cases. But most of these cases, but most of the scenarios, like it is also through handled through the infrastructure optimization, because that's how you need to scale the model, process the model in parallel, so that we can bring down the cost. Uh, Apart from this, so I'm going to discuss about the prompt engineering, how that is affecting the foundational model. So basically prompt is in today's world, like prompt engineering involves in constructing and optimizing the input prompts, and based on the input prompts, right, it will basically guide the model's behavior. So there are like there are different ways to check like how the model's behavior is, uh, right? And the foundational model can be directed by prompt and learn specific task, which is a massive advantage for us. Like the significance of it, it provides like model accuracy and adaptability, and direct the models aligned to the task requirement. So there are specific prompt template is there. The template that we use for structured format, right, to translate any language from X to Y or sentiment analysis or different kind of task. Also we have like few shot learning, like it provide like uh, prompt for better generalization. So there is zero shot, one shot, two shot. So basically it's used for more context aware response when we need, right? So we can put more context. The iterative refinement is like continuous testing and improvement. Suppose the first time when we run the model we got some output, but then based on the feedback, right, if we can improve our data or the prompt, the next time we might get a better result. So iterative refinement is also a part of building good foundational model. Also contextual prompting is required, like if I need to do a particular specific task, then I have to also like provide the more context related to that task. So that kind of helps the output of the model. And then we have a multi-prompt strategy, basically combining and chaining the prompts for complex tasks. Like maybe we can create a workflow, like say for an example, after the task one is completed, if I want task 2 and 3 has to complete, then if there is any dependency, so that we can also handle using multi-prompt strategy, and we can apply that to our model. Um, so this is the standard prompt template. Basically, it's a structure format. It's designed to provide clear and consistent instruction for AI model. It ends ensuring that the better understanding and output generation, and it also ensures like clarity and maintaining a consistent structure, like translating a text into French or French to English, and it's helped align the model's output. We generally use the prompt template, a standardized prompt template for different tasks, like in translation task or summarization or a data extraction. These are the different kind of tasks that we use, just like similar to the BART model. The BART model does the same thing. So basically, it goes to the line by line in a sentence, and it will extract the named entity. So that's another example of a foundational model, like BART is there, and I think GPT is also there. So BART does the sentiment analysis, translation task, and extraction of the named entity. So we can see how BART is performing today. Next is like the few shot learning and the iterative refinement that we are doing in the foundational model. We can like design input prompts which will guide the model's behavior effectively, and how we will do is like using the few shot learning. So training a model with a limited amount of labeled data, and typically under like 10 example per class. Basically, that means like we can first try at the first instance with a question, and we can see what is the response coming, and then maybe we can provide like more details to it, which can provide the tailored output, right? So and there are different techniques to it. Like one is the transfer learning, one is the meta learning, and one is the pre-trained model. um, is another that we used like in GPTs and BERTs. And iterative refinement, as I said, like it's a continuous improvement of the model performance through repetitive fine tuning. Like it can be a feedback loop that RHLF generally uses, right? It's a human feedback loop that which goes through the loop, and based on the initial predictions and the errors, it will again provide feedback and fine tune the model, and again rerun for the better results. Similarly, we have like active learning also, which is like informative examples of additional trainings. So combination of these two, basically few shots and iterative refinement, is it has a more advantage. The iterative process adapts the model understanding and allowing the better generalization and accuracy. And the significance of it is accuracy, adaptability, and direct models to align with the task requirement without retraining. Apart from the few short and the other one, we have the contextual prompting and the multi-prompt strategy as well. So in the contextual prompting, like generally we prefer like tailoring the prompts with relevant context to guide the model towards the more accurate and context-aware responses. And then for multi-prompt strategy, we use like multiple distinct prompts in parallel, right, to gather diverse insight and improve the model robustness. So like basically combining the results from different prompts and increase the reliability. And also like sequential prompting is there, which is breaking down the complex task into smaller manageable prompts. That also can help us to help the model to train step by step and provide the tailored output. So so the and it will also reduce the ambiguity and improve the accuracy of the overall model. And the last is like future of prompt engineering. Basically, it's an integration of AI-driven tool for any automated prompt creation or refinement. I think automation is everywhere, and we are using that for our sake, right? To create automatic prompt or context aware for if it is healthcare industry, the prompts we can create the questions or questions related to the healthcare, right? And then we can use that as a prompt to the model, and so that we can get a tailored output. So